In this video, I'm going to explain how the easy calculation based on a node consumption works. And to start, we have to click the Start button here. First thing we can always do is enter some project data, but we're going to skip this and go straight to the calculation. And this calculation is usually used if we want to exchange an old heating system for a new system. So the first thing we have to do is enter or select current or old heat generator. We can choose between a natural gas-fired boiler, oil-fired boiler, or an electric heating system. If we use electric heating, we can choose between convection and infrared. If we choose an oil-fired boiler, we can enter our consumption also in liters. But in this case, let's say that we have the old system is a natural gas-fired boiler. We can select non-condensing or a condensing system. If we select the non-condensing system, we see that the efficiency of the old heating system is about 75%. If we say, or if we select a condensing system, the efficiency will be a lot better. And the efficiency for condensing system is determined by the return temperature. So the lower the return temperature, the higher the efficiency of the old system will be. But in this case, let's say that we have a non-condensing system. Let's say that we know the consumption in kilowatt hours, so not in cubic meters of gas, and let's say that the known consumption is about 20,000 kilowatt hours a year. Domestic hot water is also produced by the old gas boiler, and let's say that there are 3 people living in the building. We can also select whether the people in the building will cook on gas, yes or no. Let's say no in this case. And year of consumption was 2023. Next step is that we need to determine the amount of operating hours. There are 2 ways to do this. So first option is just to select a predefined profile. If we say that the heating is on in the mornings and evenings, we will see that we have 10 hours a day that heating is on weekdays and weekend days. If the heating is on during the entire day, it's 14 hours a day. And we can also say that the heating is on day and night, and then it's 24 hours a day. We can also enter all of this information in more detail. And then by default, we say that the heating season starts in October and ends on the 15th of April. But we can enter these dates in detail if we want to. Outside temperature, heating on, this means if it's colder and then 16 degrees on the outside, we assume that the building will be heated on the inside. Amount of hours that the heating is on weekdays and weekend days. 20 degrees is the inside temperature of the building, and nighttime reduction, if we say that the heating will be a little bit lower during the night, we can select a nighttime reduction here. But let's assume, or let's just use a predefined profile, and let's assume that the heating is on during the day. Savings, for now, we're not going to determine the savings, and let's make a calculation. And in this calculation, we see that the power that we need is a little bit less than 10 kilowatts, so 9.68 kilowatts. Now, how is this calculated? So we start with 20,000 kilowatt hours. We assume that a part of this 20,000 kilowatt hours will be used to heat up the domestic hot water. There's no cooking on gas, and so in this way, first thing we do is to calculate how much of this 20,000 kilowatt hours is actually used to heat up the building. And this consumption is then spread out over all the operating hours. So because we know the consumption profile, in the background we can calculate all the operating hours, so the hours that the heating was on. We also know the year of consumption. So we know, so in the background we have all the climate data for 2023. So we know for all the operating hours what the outside temperature was, and we look specifically at the outside or the operating hours when it was really cold outside. And if we spread out the known consumption over all the operating hours, and we know the climate data, we can determine, or we can look at the coldest hour of the heating season, and that's how we can determine the peak heat load. And in this case, the peak heat load is 9.68 kilowatts. We can now also determine the savings. And let's say that the old gas boiler will be exchanged for a heat pump. So let's choose an air-water heat pump. Let's choose an efficiency of 450%. So this would be a seasonal performance factor of 4.5. If you don't know the seasonal performance factor, it's also possible to use the COP or the coefficient of performance. And if you only have a coefficient of performance, it's best to use a coefficient of performance with an at an outside temperature of 2 degrees. That's about the average over the heating season. But yeah, it's better to use the seasonal performance factor. But here we assume an efficiency of 450%. We also see the price for electricity and natural gas. We update these prices in the background about every 6 months, but you can always change these numbers manually as well. And then we can make a calculation and then see for the current heat generator, the consumption cost would be about £1,360 a year. For the heat pump, it's a little bit less, £1,181 a year, and that gives us a savings of about £180 a year. Sometimes, or maybe you want to work with 2 heated generators, that's also possible. Then we speak about a hybrid system or a hybrid heat pump. And then the first thing we have to enter is the split. So let's assume that the heat pump is on 90% of the time, and the natural gas boiler, so the backup system, is on 10% of the time. Let's say that we have a condensing system with a return temperature of 50 degrees, and then we have an efficiency of about 95%. And then again, let's make a calculation. Let's watch this number. So if we make our calculation again, the savings will be a little bit lower because the heat pump is not on 100% of the time. And in this case, we have a savings of £161 a year. You could also use the heat pump selector to determine the heat pump that you want to use in more detail. And then we start from this number, so 9.68, that's the peak heat load, and that's the heat load the heat pump at least should be able to generate. If we look at the heat pump, an important number here is the design factor. So we see that we show heat pumps in this list that have a design factor between 1 and 3. So that basically means that we show heat pumps that could at least, or can at least produce the peak heat load, and that the maximum heat pumps, or the biggest heat pumps that we show here, can deliver 3 times the peak heat load. So we see a detailed list of all the heat pumps that are in our database. If we, for example, select the Valiant heat pump here, we see more details of this specific heat pump. And if you want more information about how the heat pump selector works, you can always press this button, and then if you do this in the heat pump selector, you get an instruction video for the heat pump selector, and here you have more information about how this works. So let's select Valiant heat pump, then we go to the report. We can select that we want the heat pump on the PDF report. You could also add some extra remarks on the PDF report if you want to, but let's not do that in this case. And then we can click on the report button, and this will generate a PDF document that looks like this. So we have all the data that we entered in the calculation, the information for the heat generators, and we see the power, the heat load that we need, and also the savings that we can generate. And in the end, we see the heat pump that we selected and a little bit more technical information about the heat pump.